All right, let's get started. 3D calculations. What do we have here? Let's have a look. All right, let's read with me now. So it says the Smiths recently had a pool built in their back garden. The pool is 50 meters long and 8 meters wide, and the depth of the pool is 1.5 meters. A diagram of the pool is given below, and all the dimensions in the text are on the diagram. Always check that the numbers in the text are shown on the diagram because you hardly ever read the text again. You'll read it once or twice, and then you'll always refer to the diagram for your questions. Okay, sentence underneath here says the pool walls need to be tiled to keep maintenance to a minimum. Yes, you put tiles on pools to keep maintenance to the minimum. The pool walls need to be tiled. So we need to calculate number one, the surface area of the walls of the pool, giving our answer in meters cubed. And they give us a formula for this. We don't have to worry. There's the formula. We just substitute into that formula and get an answer out. All right, so it shouldn't take you guys long to do that. Have your calculators there, book and pen ready. Try this one out. There's the question, and there's the formula at the bottom there. Surface area of the walls, just the walls. Substitute the values in and determine the surface area of the walls. Should take you about 2 minutes to do that. When you're done, just put your answer online so we know when everyone's finished. Nice, easy one to start off with. Just substitute into the formula and get your answer out. All right, just let me know when you guys are done. Give us a thumbs up, or you can put your answer into the chat. All right, guys, is anyone done? Anyone got an answer there? Tando, you got an answer yet? Zahir, there we go. 180, all right. Tando's got 180 there. Anyone else with an answer? We're going to check it now. Anyone else? This is just Tando tonight. All right, Tando, we'll have to go run with yours tonight. Let's have a look and see how we do. So what I'm going to do is we're just going to write the dimensions on top of this formula here to see what goes where. So we know the length is 15 meters. The depth is 1.5 meters. The width is 8 meters. And the depth again is 1.5. All right. So we get our calculators. And we put this into our calculator. Now I'm going to use brackets for the two halves of this formula. You don't have to. But you know me, I like to use brackets. 1.5, close that bracket. And we need to add that to 2 times 8 times 1.5. All right, there we go. There are all the numbers into the formula. And we press equals 69 meters squared. 69 meters squared. Did we all get that? By the way, I'm going to take the brackets away just to see if it actually makes a difference. Let's take the brackets away. And we can show you guys that it doesn't really make a difference if the brackets are away. You still get the same answer there. All right. So that's not a problem. Do we all get that? That's all right. That's okay, Tano. Don't worry. All right, as long as you check what you did and what we did here to see where the difference is, that's all that matters. We can easily correct. Easily correct as we go. All right, not too bad, not too difficult. Let's go down. Ooh, yeah. Let's go down to question number 2. Here we go. Calculate how much water is needed to fill the pool. Give your answer in kiloliters. Ooh. Now, before we do that, I need to give you a conversion. So 1 meter squared is equal to it's 100 times 100 times 100, 10 times 10 times 10, which is 1,000. 1 cubic meter, sorry, not square meter, 1 cubic meter is equal to 1,000 liters. All right. So I'm going to just move this up here, and then I'm going to bring question 2 up so we can see it here. All right, hold on a second. Let's bring question 2 there. There's question 2. Oh, sorry. Sorry, guys. This is question 2. We're going to do the volume 1 after this. Sorry. There's 2 question 2s. This is why I'm getting confused. All right, let's do this one first. Sorry, guys. Okay, so we're talking about the tiles. So we worked out the surface area is 69 square meters. Now we get question 2 here. It says, if the tiles used measure 20 centimeters by 20 centimeters, calculate how many tiles will be needed to tile the pool walls. All right, let me help you with this. We need to know how many of these tiles will cover the surface area that you see here, 69 square meters. Okay. But first, before we do that, we need to work out the area of one tile. Now, our surface area, I'll write here, is 69 square meters. And we need to work out the tile area. I'll say tile area. You all know the area of a tile, whether it's rectangle or square. You can use the formula length times breadth, or side times size, because it looks like a square here, but length times breadth will work. So now we're going to say the length of the tile times the breadth of the tile. But before I do that, I don't know if you've noticed, the units of the tile and the units of our surface area are different. And you know this causes problems. We've got to work with the same units. Okay, so we've got to change one of these. Either we're changing square meters into centimeters squared, or we're changing centimeters into meters. I think the best thing to do is to change the centimeters into meters. So before we put it into the formula, not after, before we put it into the formula, I'm going to do this. Take the length, 20 centimeters, and change it to meters. How do we change centimeters to meters, everyone? You can type it in chat. How do we change centimeters into meters? What do we do? Come on, everyone should be able to do this. We are not going to convert to 100. We're going to use 100. We're going to use 100. We're going to divide by 100. All right, because there's 100 centimeters in a meter. Yes, Jamal. So we're going to divide by 100, and this will give us 0,2 meters. You can check down the calculator if you want. And the breadth is exactly the same. 20 centimeters divide by 100, because there's 100 centimeters in every meter, gives us 0,2 meters. Now, you must convert before the formula. Please remember that. All right. Then we're going to put this into our formula. I'm just going to move this over slightly. So now we can go to our tile area formula, and we can put in there 0,2 meters times 0,2 meters and get an answer here. 0,2 times 0,2. This gives us 0,04. 0,04 meters squared. Okay, because we're using meters now. And this is good because we got meters squared for the surface area of the walls. Now we can actually work with this. So one tile is 0,04 meters squared. The whole surface area is 69 meters squared. So to work out how many tiles we need, we are going to say 69 square meters of surface area. Cut it up into tile pieces. How many of these will we get? 1725. Yo, 1725 tiles. That's a lot of tiles. Well, tiles are about that wide and that long. It's quite a big pool. Yes. All right. So this is our final answer here. This is how many tiles. So let's just go over this one more time. They want to know how many tiles can we put along the surface area of this pool. So we know the surface area is 69 meters squared. We have an issue in that our tile sizes, the dimensions, are not the same units. So we had to quickly, on the side here, convert our centimeters into meters, and then work out the area of one tile, which is 0.04. And then we can say this total surface area divided by the area of one tile, and that'll give us however many tiles we need. All right. Any questions? You guys happy with that? So this is step number 1, convert. Then step number 2, work out the area. And then step number 3, divide the total surface area by the area of a tile. All good with that one? Not too bad. All right. Okay. Ladies and gents, remember, if you're not sure about anything, please speak. Don't hold your peace. All right, finally, we get to the number 2 that I wanted to do. Here we go. It says, calculate how much water is needed to fill the pool. Give your answer in kiloliters. All right. Now, I'm going to move this question up again as well. There we go. A new number 2. And we're going to need this conversion here. How was I rhyming? I'm practicing for the album. Was I rhyming? I didn't even notice. What did I say? I'm practicing for the album. To do. I'm a natural, Tiamo. I promise you, I'm making an album. We're gonna get a famous DJ and we're gonna make an album. The Watobe Mathlete album, Volume 1. All right, here we go. We need to work out the volume of the pool. And we need the volume in kiloliters. Now, I've given you this conversion here at the top, that 1 cubic meter is equal to 1,000 liters. Now, how many liters in a kiloliter? 1 kiloliter is how many liters, by the way? Does anyone know? 1 kiloliter is how many liters? Yes. Atlechile, well done. 1 kilometer is 1,000 meters. 1 kilogram is 1,000 grams. 1 kiloliter is 1,000 liters. Yes, you guys know. All right, so just remember that, eh? 1 kiloliter is 1,000 liters. And we know that 1 cubic meter is 1,000 liters as well. So these two things here, the cubic meters and the kiloliters, are actually the same. In fact, we could actually say that 1 kiloliter is the same as 1 cubic meter. All right, that'll help us. That's a 1-to-1 conversion. Perfect. Let's work out the volume of the pool. V equals length. I think they said was 18, 15. Come on, you guys, you can do it. Get the calculators out. Give us the answer here. 15 meters times the width is 8 meters times the depth is 1.5 meters. What is the volume of the pool? Fastest fingers first. Let's see. Who can give me the volume of this pool? 180. Sianda. Good job. Well done. 15 times 8 times 1.5. Yes, Sianda. Fastest one. Well done. 180 meters cubed. All right. So how many kiloliters? All right. Well, we know that 1 kiloliter is 1 cubic meter. So therefore, it's 180 kiloliters. Don't worry, Kian. Don't stress. We're busy with measurement. Working at the volume of a pool in kiloliters. All right, so it's a one-to-one relationship. So if it's 180 cubic meters, it's 180 kiloliters. Easy, guys. Easy, easy, easy. That's not difficult. That's not bad. All right, but this here, if you guys are worrying like, well, how am I supposed to know about these conversions? This top conversion that's highlighted in yellow, 1 cubic meter equals 1,000 liters, that will be given to you. In fact, the others might also be given. This bottom one might also be given to you here. All right. The top one will definitely be given to you, or the bottom one will be given to you. Okay, so you don't have to know that off by heart. All right. They will give that to you. Excuse me. Okay, let's move on to the next question. What else they got for us about this pool? Done that one. The second question too. Here we go. Water costs 5.555 rand and 55 cents per kiloliter. How much will it cost to fill the pool? And we said the pool was 180. 180 kiloliters. Everyone should be able to do this. And it costs 5 rand 50 per 5.55 per kiloliter. Everybody should be able to get this one. Come on now, guys. Yes, who's first? Tato, 180 times 5.55. Whoopsie, what's going on? Why is my calculator not working? 180 times 5.55, please. 999. Exactly 999. Wow. Exactly 999 rand. Good. Yes. Easy, easy, easy. Nice and easy. Huh. What else do they have for us? Question 4. Let's have a look. Let's have a look. Last week, in fact, today feels like it. Last week, the maximum temperature reached 39.5. Guys, it's hot today. What's the temperature there by you? It was 31 degrees here today. 31. Can you believe it? What's it there where you guys are? What is the temperature where you guys are today? I'm sure there's places out there that were hotter than 31. 50. 50.
I might
Yeah,
be exaggerating, but it feels like a 50.
it felt like a
It
50.
feels like a 50.
Yeah.
I've
So
never
it's
felt a 50 before, but
no,
it
neither
pretty
have
much does.
I. 32 title. Yo, guys, it's hot. It's definitely ice cream time. Uppington. Tiamo, that is the worst. Uppington is hot. Uppington gets really hot, eh? Sure. Okay. It's dry there as well. All right, let's have a look at number 4. Talking about pools, and we all hot. Wish we had a pool, actually. I wish I had a pool. It's raining and very windy. Where are you, Kian? That it's so windy. There's no wind here. It must be in the Cape. Yeah, thought so. But the Cape Town's always windy, eh? All right. So we got 180 kiloliters of water in this pool. They say last week the maximum temperature reached 39.5 degrees Celsius, and because of that, 1.5% of the pool water evaporated. How much water evaporated out of the pool? Now, they don't give us the units to work with here. They don't ask how many liters of water evaporated, they just say how much. So we can use the kiloliters, we can use the liters, whatever. But let's work with the kiloliters here. 1.5% of this evaporated. How much is that? Come on, guys, you can do that. 1.5% of this water, 180 kiloliters, gone. How much is that how much water is in that 1.5%? You guys should be able to do this. 1.5% of this pool water, What's the answer? Who's first? Let's see who gets it first. Come on, let's see who's first. Fastest fingers first. 1.5% of this 180 kiloliters. All right, Tato's saying, is it 2.7? That looks pretty good, Tato. That looks pretty good. Anyone else? Is Tato the only one that's got an answer? Yeah. Atlichil is also 2.7, Katlego 2.7. All right, very good, very good. So we need to say 1.5% of this. Nice and easy. All right, so 180 times 1.5 over 100. We know how to work out a percentage. 2.7 kiloliters of water. Don't forget the units. Yes, you all good. You all got it. Well done. Excellent. Excellent, excellent, excellent. All right. That's the warm up. Talking about pools, you don't mind if we start going down into deeper waters now, do you? You guys are good swimmers. I've taken you into the deep waters many, many, many times. Damn, it's okay. I'm a trained lifeguard. All right. Don't worry. I will save you. Don't worry. I'll be there with you. Okay. I've got the oxygen tank. I've got all the safety gear. I will be there with you to keep the sharks away. All right. Study the fish tank below. And answer the questions that follow. Similar scenario, isn't it? Fish tank. By the way, what type of shape is this? Anybody, what type of shape is this? Yes, Tando, you are a good swimmer. You don't mind the challenge. What type of shape? It's got a name, this 3D shape. What is the name of this 3D shape? Everyone's furiously typing long words and rectangular prism. Yes, rectangular prism. Very good. Yes, well done, guys. Rectangular prism. What do you notice about this diagram, ladies and gentlemen? Yes, well done, Dine. What do you notice about this diagram? Besides the colors and then it's a fish tank. What else do you notice? You remember you're a math lit student. You should be picking up on things. What do you notice about this diagram? Inches. Yes. Inches. All right. So when you see inches, maybe they'll ask you to convert. All right. Expect it. They give you an imperial unit and not a metric unit like we've been dealing with so far. Maybe they want you to convert. So keep an eye out for that. Okay. Yes. We've got inches here. Everything's in inches. Everything's in inches. I don't know why. Maybe it comes from an American scenario. Maybe they're just trying to trick you. Let's see. All right, question number 1. Calculate the volume of the fish tank in cubic inches. Now, that's something we haven't really done before, calculating volume in cubic inches. All right, there are the dimensions. Calculate the volume of the fish tank in cubic inches. Come on, we're pros at this now. We say, where's the formula? There's the formula. Sub into the formula. Sub into the formula. Not that difficult. Not too bad. Who's first? Tando, well done. 2556. Tato as well. 2556. All right. 2556. Keon, good job. Well done. Okay. 30, 12, and 7.1. All right. Just easy substitution. So 30 inches times 12 inches times 7.1. Sub it all in. Notice how I'm writing the units. Hey, I know what you're thinking, guys. Why do we have to do this? So I don't have the time for this. I'm not that kind of a person that always writes the units every single time. That's fair enough. I understand it completely. But 2 reasons. Number 1, because Kia said so. And number 2, Because if there was a unit that was different in here, like feet or something, you would pick it up. You'd see it. You'd say, "Oh, I've got inches, and then feet. That's not right. Got to work with the same units." So writing the units down does help. That's why I suggest it. Not to make your life more difficult. I mean, the water's deep enough. So 30 times 12 times 7.1. 2556. You guys are too good. Cubic inches. We've never really worked with cubic inches. All right. Now, here is a side question for you. If I gave you a conversion that 1 inch is equal to 2,8 centimeters, and I wanted this answer in centimeters cubed, what should I do? I need someone to come online and tell me what I must do. If they gave you a conversion and they said, we want this answer in centimeters cubed, what should I do? I need someone to come online now. Anybody out there? Tando. My man. Tando.
Good day, sir.
Good day.
How
How
are
are
you,
you?
sir?
I'm good, and you?
I'm good. I'm good, thanks, sir.
Good. What should we do
Sir,
if you want to get centimeters cubed?
first thing, sir, we are going to convert inches to centimeters.
Yes. So you'll say 30 inches times 2,8. 12 inches times 2,8. And 7.1 inches times 2,8. Now, Tana, just hold on a second. Ladies and gentlemen, if they asked this question, determine the volume of the fish tank in centimeters cubed given this conversion, 1 inch equals 2,8 centimeters. I know for a fact that without you guys practicing this, a lot of guys are going to take this huge number here at the bottom, the 2556, and try to do something with it. They're going to divide that by 2556 or times that. Sorry, they're going to times that by 2,8 or divide it by 2,8 or something like that. You
Yes,
don't
sir.
work. You don't work with the cubic units or square units. Always convert the original dimensions first, like Tando suggested here. All right, so let's just quickly, Tando, I'm just going to quickly calculate this. So let's just quickly do this, and I'll show you guys how it works. So 30 times 2.8 is 84 centimeters. 12 times 2.8. Whoopsie. 12 times 2.8 is
19,88.
what? Check your calculator there. 12 times 2.8, 33.6.
Oh,
And the last one, are you talking about the last one? Sorry, Tando. You were talking
yeah.
about the last. Sorry. 19.88. Sorry. 19.88 centimeters. And then you take all three of those, you throw it into the formula, and it'll give you your answer in centimeters cubed. So please, if you want to work from imperial volume to metric volume, don't take a imperial volume answer and try and convert that. Take each dimension in there, convert it to metric, and then put it back in the formula and get your answer. All right. You got it,
Thanks, sir.
Tando?
Yes, sir.
Excellent. Thanks for your help, young man. I appreciate it. Yes, and there's Kian giving us what the answer would be. It would be 56,109,312 centimeters cubed. If you wanted to know, that's what it would be like in centimeters cubed. So just please remember, if you're working from area or volume in imperial units, and they say, give us this now in metric units, don't fiddle with the answer. Take all the dimensions, change them first, and then go and put it into your formula. All right. I hope you guys remember that. Let's see. Now, this is the big one. This is the big one. All right. We've just got this answer here. I'm just going to put it here on the screen for question 2. There it is. This is the volume of the pool. We'll keep it in inches just for interest's sake. This is the volume of the pool. Not the pool, the fish tank. They say the fish tank is 85% full for some reason. After adding stones to the bottom of the fish tank is now 97% full. Calculate the volume of the stones. Ay, 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 ay. I didn't just take you into the deep, dark waters. I strapped stones to your feet as well at the same time. I don't make it easy, do I? Guys, what do we do here? Who's got an idea? Someone out there has got to have an idea of what we do here. We've got the volume of the fish tank. By the way, the fish tank is 85% full. After adding stones, the tank is 97% full. Calculate the volume of the stones. Yeesh. Who is going to help with this one? Someone out there. Sure. Keon, if you're right, that's very good.
On a day this hot, we can't be having crickets. That's just so unfair.
Yeah, Keon, that was so fast as well. Crumbs. Tato's got an answer already. What? I thought I'd stumped you guys with this. I thought we were gonna wrestle with this one. I need someone to come online and explain how we do this. Who haven't we heard from before? Zoe Bowman? Zoe Bowman, are you out there? I can't even unmute these people. All the last 4 can't even unmute, can't even talk to them. Zahir, are you there? Oh, it's ghosts. It's crickets, Kia. It's crickets out there.
On such a hot day.
Yeah, everyone's not feeling it, eh? Viwe? Ti amo? Tato? Come on, guys. Who's gonna help me here? Check your screens there. Sianda? Sitoko Zile? Check your screens, guys. Someone's gotta help me out. Katlejo's got a different answer as well. Guys, check your screen. Someone's got to respond. Someone's got to answer. Is there anybody out there? Atlechile? Oh, guys. Oh, Tana, I appreciate your efforts. I'm looking to see if these other people are awake. I think everyone's hot and tired and catching a nap here somewhere. All right, let's do 2 ways. Let's do 2 ways. Okay. And unfortunately, I'm that kind of a person that always does a long way. But we're going to do Keon's way first. I love how Keon's actually approached this question. We'll do 2. Yes, Tato, that's pretty much the same. So what Tato and Kiana are suggesting is saying, what is the change in the percentage of the tank? It went from 97 to 85. So they're saying, take the 97% and the 85 and find the difference in the percentage or the change in percentage. All right. And that gives us a change of 12%. So the tank's volume changed by 12% from 85 to 97. So that volume change of 12%, how much is that in volume? Well, they just said, well, take the 12%, all right, 12 over 100, and apply it to the volume of the tank. Let's see. I thought I stumped you guys with this one, really, and you surprised me. It's all this swimming training. 306.72. So 306.72%. Now, often you guys, when you put your answers on chat, there's a question mark there. Like, I think it's this. You know that in math literacy, there's a skill to... Keon, that's a good question. I think you'll get all your marks for this. There's nothing wrong with it. Sorry, it's not a percent. It's cubic inches. There's nothing wrong with this question. I mean, this answer. Absolutely get your marks for this. Now, one thing I want to show you is how do we know if this is kind of right? Okay. Well, in math literacy, there is a skill that you might have been taught in grade 10 called estimation. Okay. So it's estimation. Now, we can estimate and see if this is right. So what we can do is we can take out 2556, a quick estimation, and we can say, what is 50% of this? What is 50% of this? Cut it up into 2. That's 50%, right? It looks roughly like 1 to 1 to 250, and then another 25, so 278. It might not be wrong, but you're just estimating, okay? So that's 50% of the tank. All right. What if we take the 50% and cut it into half again? Let's cut it into half again. 50% of 50%. That's a quarter of the tank now, isn't it? We're cutting the half into a half. That gives us about 6, what's half 70, 35, and 4, so 39. So 639. About 639. Doesn't have to be perfect. That's 25% of the tank. Well, what if we take this quarter and we cut it in half? That's an eighth of the tank, isn't it? So 639, cut that in half. This will give us an eighth. A quarter, half of a quarter is an eighth, right? So half of 639, what's it? 3, so 640, what's half of 640? 320, so it's about 320. All right. And that's half of 25%, which is 12.5%. We want 12, and about 12.5 is about 320. So our answer, which is 12 for 12%, is very close to 320, which is 12.5%. So yeah. So if you get this answer, you're like, oh, I don't know if this is right. You can use estimation, a quick little calculator, not during the exam, not during, at the end. If you're worried about it, you put a star next to this answer, which means I'm going to come back to that, and you can check. All right. So a quick estimation can say, oh, actually, that figure is pretty much close to being right. It's pretty much spot on. All right. So that's Keon's method there. I'm going to show you how I would have approached this. So I would have said, well, first of all, what's 90? This is actually longer. What is 97% of the volume? So I would have said 97% of the tank in volume. This is longer, guys. So Keon's method actually seems a bit better here. Is 2479.32. 2479.32 inches cubed. And what is 85% of the tank? And you know what I'm going to do, right? Once I've got these volumes, you know what I'm going to do. So I'm going to say, in fact, let's go back to the formula and just change it to 85. 2172,6. 2172,6 inches cubed. So 97% is that volume, 85% is that volume. It went from 85 up to 97. So it's the difference between the two. So I'm just going to minus these, which is pretty much exactly the same as the method that Keon suggested. It's just that in that method, the minusing happened first. The difference calculation happened first. Let's check what we get here. So 2479.32 minus 2172,6. 306,72. Exactly the same. So two methods to work this out. I would say Keon's is probably quicker. You'd get the marks, Keon. Definitely get all 5 marks. Because I've got 2 percentage calculations there. You only have 1. And you found the difference in the percentage. I found the difference in the volume. You zigged, I zagged. We both got to the same place in the end. All right. So yeah, 2 ways to get the same answer there. Well done. Hope you guys see the second method and the first. Yeah, they're the same. You get the same answer. It's 2 different ways to get to the answer. Sometimes in math, you can have that. You can have 2 different methods getting to the same answer. So we need to work out the difference between the 2 volumes. What Keon had said, well, what's the difference in percentage first? It's a 12% difference. How do we represent that 12% as volume? Well, we just say 12% times the volume. I went and took the volumes first and then found the difference between the 2. Yeah, well done, Kian. Yeah, everyone's different. Everyone's brain works different. So when I see the sum, I think of it like this. But if Kian sees the sum, it looks a bit different. There are different ways to get there. Absolutely. Absolutely. Now, if you're unsure, like I said before, you can do a check. Like we did an estimation here. We estimated to see a quick calculation. Didn't even need a calculator. Half the pool, then half of the half, then half of the quarter gets down to 12.5%. We're roughly in the same ballparks, the same area with our answer here. So yeah, good work. I thought I just stumped you guys. I thought I had you. But you guys are too good. Way too good. Okay, so this is math. I was going to say this is math lit. This is math lit. This is the measurement section completed now. Now, often guys find the measurement section very difficult. I want you to tell me what's the most important thing, especially after all the measurement that we've done this year. What's the most important thing to remember when you come to the measurement section? Let's hear what you guys think. What have you remembered so far that we've spoken about? What's the most important thing to remember? Some tips for the dealing with the measurement section. What do you guys remember that you should do? Some hot tips. Give us some hot tips to go into the exam with for the measurement section. Come on, guys, no crickets now. Hot tips for measurement. Make sure to work with the same units. Yes. Very important. All right, hot tip number 1. Work with the same units. And this is why Ms. Kia always says show your units, because you will see if you're working with your units. Convert, yes. So know when to convert. Now, with conversions, we have metric to metric. That conversion, you guys have to know. They don't give you that. You have to know to work within the metric system. Then the other conversion of imperial to metric, that has to be given to you. Okay, so this first one you must know. The second one is given to you. Thank goodness. Make sure that after everything that you've done, double check your answer. Yes. All right. That's a very, very, very good tip. So what I suggest is if it looks like deep water, what do you do? Put a star and come back later. That's my suggestion. Yes. Convert units before calculating. Good. You got to work with the same units. All right. So if it looks like a really deep question, those, you know, those deep, deep water questions where the sharks are swimming, and you can see it. You guys know them because, like, whenever Tiamo sees them, she lets you know. Like, sir, please now. All right. So you guys recognize them. So when you see one of these things, don't get scared. Just recognize it and just take a quick glance. You might, looking at it once, you might think, oh, actually, I know what to do here. All right. Or you look at it and you're like, I know what to do. Oh, no, hold on. I don't. Yeah, no, I don't. Okay. You feel unsure. Leave it. Move on. Put a star there. Leave half a page in your book, in your answer script. Move on to the next question. Okay. If it is the last question, the deep, deep, dark water question, then you go back to the beginning of your exam and you go and find all the other little ones that you're not sure about first, and then you come back to this deep one. All right, because every exam has questions like this. And for those people that want to excuse me, for those people that want to get their 80s and 90s, those are your questions. All right, they're in there for you. So you have to try them if you want to get your 80s and 90s. So if you're not sure, you go back and make sure you do all the other questions well, and then you come back. There's no point in sitting on a 5-mark question for 25 minutes. That's a waste of time. Okay, that's a waste of time. Do not sit on, especially if this 5-mark question is in the middle of your exam. Please, ladies and gentlemen, please do not spend 25 minutes on a 5-mark question. All right, you will know if you can figure it out. And if you try it and then you get stuck and then you cross it out and then you try it again and you get just move on. Go and finish the rest of the exam, put a star next to it, and you come back to this one and then you try it again at the end of your exam. All right, don't wrestle in the middle of the exam with a deep dark water question that's 5 marks long and you're taking half an hour. That's not wise. All right, so leave a space in your book. Carry on. Finish all the easy ones, and you come back and you wrestle and you swim with that shark. All right. And you get to know him and make him your friend. Okay? But at the end of the paper, not in the middle of the paper. Please. All right. Okay. Ladies and gentlemen, I think we're going to call it an hour. Are there any questions? Anything else